And the downside.
Yeah. All right. Well, welcome everyone um, to another Climate Link meetup. It's our first tech talk of the year, I think. I don't know. I have a 6-month-old child, so my short-term memory is pretty short. Um, welcome everyone. Tonight we're covering demand response and automated emissions reduction with our two speakers from Olivine and Watt Time. So we have Abigail Shelton, who's the lead engineering solutions from Olivine, and Henry Richardson of Watt Time. Oh, come on. There we go. So if this is your first time to Climate Link, we are a network and not just a meetup group. So we try to be helpful to each other, and we're about to start a book club, thanks to Aaron, who's spearheading that initiative. But really our goal has always been to help ideas get from inspiration to IPO, from eureka to exit, from cradle to cradle. So it's building out the support network to help ideas. It really started off connecting ideas and startups to the most appropriate capital source, not just going straight to VC from the lab. And we've even had one marriage come out of this. So Climate Link is sponsored by Atmos Financial, which is the most climate positive banking institution on the planet. It is not a bank, but it provides FDIC insured bank accounts. And that stat is now wrong. It's over about 50 times the national average on savings. Atmos is my startup, and I can tell you all about it. Basically, if you work in clean energy or work on climate, you shouldn't have your money in your bank account funding fossil fuels. And so this is, after 2 decades in this space, this is the bank that I always wanted. And so I work to help launch it. You can get an account in just 2 minutes. And I hope you will move your money there so that it can fund more cool projects like utility scale solar and soon resi and commercial, as well as storage. So some Zoom networking best practices: keep yourself muted unless you're speaking, ask questions in the chat back and use the raise hand feature, and then introduce yourself in the chat. It's kind of like old school when we exchange business cards, but now you can do your LinkedIn or email and say what you can offer to others and what you might be in the need for. Like if you're looking for a job or you're offering jobs, and yeah, and connect with others. So we've got our old videos up on YouTube, and at one point there was a newsletter, and I've got some in draft form I'll be sending out shortly. And most importantly, we've got more talks coming up. So next month, we're diving into beyond just our own personal carbon footprint, which a lot of the Climate Link talks have been about. We're really getting into our carbon influence, our carbon shadow. And so this goes beyond our own individual actions and our own individual impact. And one of the most impactful things that people can do is vote and be engaged politically. So we've got some really cool nonprofits that'll be presenting next month on the data and about how impactful we can be. We're going to be covering heat pumps, carbon dioxide removal and use, and also happy hours. So both virtual and in person, as the weather gets nicer, as restrictions loosen and guidelines says that it's safe for us to visit with each other, and we also feel comfortable with it. So without further ado, I'm going to let Abby and Henry do their own intros because they will do a much better job than I can. And I believe, Abby, you are going first.
Yeah, so hi, I'm Abby Shelton. Like Robbie said, I am the leader of engineering solutions at Olivine, and I manage several innovative demand response and distributed energy resource projects and programs for Olivine. And I am currently working on.
Excuse me, Abby. Yeah. There's something going on with your audio. There's a bad feedback or something. The mic is not picking you up well.
Okay, let me try to switch. Is it any better now?
It's a lot better.
It is better?
Oh, it was.
It was. How about Henry introduce himself, and I'm going to try a different audio option.
Absolutely. Hi, everyone. Is my sound quality okay?
Yeah.
Excellent. I got a thumbs up. I'm Henry Richardson. I'm here at Watt Time on the analysis team. And Watt Time's a nonprofit that really focuses on bringing energy choice to people. And I'm going to go into excruciating detail in how we actually do that and enable that through signals and device partner integrations and things like that. Abby, did you have a chance to find a new mic?
Let's try this. Is this any better? No.
We're getting almost like a rattling sound.
Let me try one other option.
Okay. Yeah, great point, Aaron.
All right, can you hear me any better now?
Yeah, it is a lot better.
Great, thank you all for your patience. I typically use Teams, and I don't know if for some reason there's something different about Zoom. But thank you for your patience. And so let me finish my introduction. I am Abby Shelton. I am a lead of engineering solutions at Olive. And I manage several innovative demand response and distributed energy resource projects and programs, one of which I'm going to talk about today, which is the PG&E's implementation of the emergency load reduction program. And with that, should I go ahead and get started with my slide deck, Robbie?
Yes, please do.
All right. Okay. Can you all see my slide deck? Great. All right, so today I'm going to be presenting on PG&E's emergency program for mitigating climate change induced grid emergencies. It's the Emergency Load Reduction Program, or ELRP. And I've already introduced myself, so I'll skip this slide. So what I'm planning for the presentation today is to give a quick overview of Olivine, the company that I work for. Give a quick overview of demand response, because the rest of the presentation is going to be talking about demand response program. So just want to make sure for those folks that aren't maybe as engaged in demand response that they have that basic understanding. Then I want to talk about the emergency load reduction program, but before I get there, I want to talk about what led up to that. And so it's starting with the California summer of 2020, the heat wave that we experienced, the impacts that it had on the grid, and then the response. So talking about that lead up to the launch of the emergency load reduction program. For the program, I'll talk about the goals, the program design elements, the various participation options, and how we went about implementing it, the successes, the challenges, etc. And then lastly, I will give you a peek into what is coming for this year for ELRP, the program design changes, the new participation options, the increase in incentives, things like that. And Robbie, do you want to do Q&A at the very end, or will we do Q&A and then Henry's presentation? Okay, well, I don't know if Robbie's here, so we
I
will.
think Ravi may have stepped away. I'd say let's just go ahead and do it all at the very end. That might be the best.
All right. So any questions that you have, we'll discuss them at the end.
Sorry, I went to grab some water.
That's okay. All right. So first, let's talk about a little bit about Olivine. So Olivine provides infrastructure and program management services to utilities and other service providers with the mission of providing our clients with what they need to meet their renewable energy and GHG emission reduction goals. And so, like I mentioned, one of the programs that we help implement is the PG&E's Emergency Load Reduction Program. A little bit more detail on the services that we offer. So we support our clients in program design. We provide them with the technology to operate their programs. We launch programs and provide marketing collateral, so like program websites, flyers, FAQs, and then we help to operate the program. And so that's everything from managing enrollments to monitoring for event triggers and dispatching participants to calculating event performance and settlements, and then finally paying customers. And then the last slide on Olivine is just talking more about our technology suite. And so we have a valuation model that we use to evaluate the value that various types of distributed energy resources and different customer groups can offer. We have a climate response app where customers can download the app and they can enhance their participation in programs by viewing their energy usage, by seeing their event performance. So how much energy do they reduce during a demand response event, and seeing like how much money they earned for their energy reduction and participation in the program. We also have a technology marketplace where customers can purchase EV chargers, smart thermostats, heat pump water heaters, and then they can utilize those smart devices to participate in programs. And then lastly, we have a DR platform. So you'll hear me refer to Olivine DR at various points in the presentation. And so this platform offers a wide variety of functionality, anything from supporting wholesale market and utility program participation to event dispatch, performance calculations, settlement calculations, etc. So that's our technology suite. And then the last thing I'll mention on Olivine is that we are hiring for several roles. So we're hiring for a software developer, a development manager, and we're hiring for several software engineers. We're also hiring an engineering manager. And so a big part of that role is actually to integrate Olivine systems with third-party energy providers or third-party energy technology vendors with their systems. And then the last one is project and program managers. So I've provided a link to our careers page on our website. You can go here and then it'll provide you with a link to our Indeed page where you can view the job descriptions of each of these and apply for the positions. All right, so quick overview on demand response. So what is demand response? It is reducing or shifting the electricity usage during peak periods in response to some type of trigger. So the trigger could be wholesale market prices, it could be grid emissions, it could be grid emergencies, like what we'll talk about with the Emergency Load Reduction Program, the ELRP. And the reason that customers and the utilities and service providers are interested in demand response is because you can reduce the demand to meet the supply. It offers customers an opportunity to earn financial incentives or other types of incentives. It reduces the energy usage and depending on the trigger can reduce carbon emissions. So like Henry, I think is going to talk a little bit about WattTime's grid emissions data. And so that could be an example of one trigger that could trigger a demand response event for participants to reduce their energy usage during times of high emissions. So this diagram just shows an example of how a battery could participate in a demand response event by discharging during the event hours to reduce the load that maybe home is taking from the grid. All right, so like I said, before I want to talk about the emergency load reduction program, I would like to talk a little bit about what led up to it. So, and start with the events in the summer of 2020 in California. So taking you back to August and September of 2020, if you'll remember, we experienced an extreme heat wave, not just in California, but over the entire Western United States. I remember inside my apartment, my thermostat read, I think, 97 degrees. So it was really hot. And that put a lot of stress on the grid, everybody running their air conditioners, things like that. I don't have an air conditioner, which is why mine was 97 degrees. But it was really hot. And so the impacts of that heat wave were the real-time demand exceeded the day ahead forecast. So you'll see here two diagrams, two charts from CAISO that show the day ahead load forecast, and that's in the blue dotted line, versus the real-time load for two periods, one in August and one in September. And you'll see two spots here that are highlighted in light blue. That's when you can see that the real-time market requirement actually exceeded what it was forecasted. And these blue periods represent times that the CAISO, so the California Independent System Operator, called stage 3 emergencies. So that's the highest level of emergency. And that happened twice on October 14th and 15th due to deficiencies in reserves. And so that led to rotating power outages. They were required to shed load just to make sure that that the supply and the demand didn't get out of balance and result in worse grid failures. So those were the impacts of these heat waves. And so this was like the first time since 2001 where there's a lack of generation to meet the demand. So you'll see on the right, there's a lot of numbers here, but I've highlighted kind of what we saw in 2020 versus back during 2001 with the energy crisis. And so it was the first time since then that we experienced a stage 3 emergency. And the impacts that we in 2020, they weren't as bad as they could have been. There was a lot of voluntary, uncompensated demand response, people just knowing that the grid is under stress and reducing their energy usage. So if that hadn't happened, the impacts would have been worse. And moving forward, there's going to, renewable variability, thermal requirements, and climate change. With all those factors, we're going to see increased uncertainty like this. And you can look, this chart actually shows 2021. And while there wasn't a stage 3 emergency in 2021, there was a stage 2 one. There were a significant number of restricted maintenance operations and flex alerts. And so, there was still a lot of uncertainty. So, and then between 2020 and then looking to 2021, CAISO forecasted capacity shortfalls in the summer of 2021. So then that brings us to ELRP. So in November of 2020, the CPUC, they instituted a rulemaking to establish processes, policies, rules to ensure that reliable electric service in California in the event of an extreme weather event in 2021. And then in March 2021, the CPUC, so the governing body of the IOUs, the California Public Utilities Commission, they ordered the IOUs, the PG&E, SDG&E, and SCE to implement the emergency load reduction program by May 1st. So these utilities had 1 month to implement the program. And on May 1st, ELRP went live. And so now I've kind of caught you up to speed, and we can talk about the emergency load reduction program. So for those of you that may be outside of California or not as familiar with the utilities, Pacific Gas and Electric is the IOU that serves Northern California, and this is a map of their service territory. They are one of the largest combined natural gas and electric energy companies in the US, serving 5.5 million electric customers. And they, like I said, are regulated by the CPUC. And so the goals of the emergency load reduction program were ultimately to avoid rotating power outages and minimize costs to customers. And to do that, they wanted to access additional load reduction during these times of high grid stress and emergencies, and offer customers, non-residential customers, financial incentives to reduce energy. So a lot of these customers were already reducing energy, but compensating them and encouraging them to reduce even more. So I want to talk a little bit about the program design elements. So this program runs from May through October. It's 7 days a week, and the event window is from 4 to 9 p.m. So events could be called anytime between 4 to 9 p.m. There is a 60-hour annual dispatch limit, so there wouldn't be more than 60 event hours in a given year, and dispatches can occur on consecutive days if the grid conditions warrant. And customers are paid $1 per kWh for load reduction. It's a completely voluntary program, and so there's no penalties for non-performance. And that design element was really to ensure that customers, that they felt comfortable joining. They thought that would increase enrollment numbers. So voluntary, no penalties for non-performance. The event triggers are CAISO alert, warning, and emergency notices. And the events can happen in the day ahead or in the day of. And that is because alerts are actually in the day ahead, and then the warning and emergency notices they're in the day of. Emergency notices are pretty much immediate. And the events can last from anywhere from 1 to 5 hours. Customers were allowed to use prohibited resources. They also were allowed to export if they had Rule 21 export agreements. So if they had the interconnection export permits, they were allowed to export and be compensated for exports. And for PG&E, now the other IOUs were different, but for PG&E, the customers could enroll as long as they had 1 kW of load reduction, if they could reduce by 1 kW during an event. And I mentioned this on the next slide, but I should go ahead and point it out here, that when I say customers, they're non-residential customers, not residential customers. And so we asked customers to nominate a load reduction quantity. So I'll say the emergency load reduction program, it is actually kind of like 6 different programs in one. And the reason I say that is because there are a lot of different participation options. So they've really fallen into 2 categories. The first is customers. So customers, non-residential customers, can directly enroll in the ELRP, and then aggregators can enroll in the ELRP. And so for aggregators, this includes virtual power plant aggregators, and it also includes base interruptible program aggregators, capacity bidding program aggregators, and third-party demand response providers. And those latter 3 options, those are actually dual participation options. And so these aggregators already have existing commitments either on the market or in their programs. And what they can do is they can also enroll in the ELRP, and then if they can provide load reduction in addition to their existing commitments, then they could be compensated through the emergency load reduction program. So that was another aspect that made ELRP unique. There was a lot of different participation options, and each of these have their own eligibility requirements, their own rules. So it was very complex. There's a lot to communicate to customers. And so in that month timeframe, we put up a program website, FAQs, we developed flyers, we worked with the PG&E account reps to conduct outreach to customers, and developed tools for the account reps that they could use to figure out how much a customer could save if they participated in an event. and assuming some load reduction quantity. We hosted aggregator and demand response provider webinars to tell aggregators about what the ELRP was and what value they could get out of participating. We also put up a enrollment flow. So that's the second picture here. And that just allows customers to directly enroll in the program. A lot of easy self-service enrollment. And then once the program was live, we handled the event dispatch. So we monitored the CAISO grid notices, and if triggered, then we leveraged our platform to dispatch participants via email and text. And then on the back end, we also calculated event performance and settlements in our platform. So this picture on the right, it shows the event performance, what it would look like to a customer if they logged onto our platform. They could see how much they reduced during the event window, which is in yellow, both on the diagram and in the chart compared to their baseline. So challenges and successes. So like I said, it was a very limited time to design and implement the program. It was 1 month, and it was a very complex program, like 6 different sub-program participation options. And so it was challenging to figure out how to communicate all of those details to the various customers and aggregators. And then on top of that, there were actually some mid-season changes to the program design. The CPUC issued more orders and decisions that impacted design. The 2 areas of that are, initially it was just going to be day ahead events. There were going to not be any day of events during this first season, but the CPUC ordered the addition of day of events. And then the second change mid-season was the addition of the virtual power plant and the Rule 21 exporting DRs, those participation options. Those were also, they were planned to go live in 2022, not in 2021. So that, it wasn't just the initial design, it was like we were continuing to design and edit the program as it was going. Successes is that we worked very closely with PG&E and implemented the program in well under 2 months. It was more like 1 month. We leveraged existing relationships that the utility account representatives had with their commercial and industrial customers, and to really enroll a lot of customers in a very short time frame. And then there were, and you saw it maybe back on the previous slide, but there were 4 grid warnings and emergencies last year. So we dispatched participants 4 times in response to those CAISO grid warning and emergencies. And then looking to 2022. So last December, the CPUC ordered modifications to the emergency load reduction program, and that includes addition of new participation options. And so one of them is a residential participation option. So over 1 million customers in PG&E's territory will be auto-enrolled into the ELRP, and that's based on like if they're in an energy bill assistance program or if they're a high energy usage customer. And there's also the option for customers to self-enroll if they choose to. So big residential option that's getting added this year. There's also 2 new aggregator options. So a vehicle to grid aggregator option, and then a non-residential aggregator option, which is, it's kind of like there's not anything really special or unique about it. It's kind of like very similar to some of the existing ones. It just opens up a new opportunity that some people may fit into. But the big ones are the V2G aggregators and the residential participation option. They're increasing the incentives from $1 per kWh to 2, so they're doubling the incentive rate. They are adding minimum dispatch hours for some of the aggregator options. And so previously there was, participation was voluntary. You could sign up, and then depending on whether you could respond or not, you weren't going to be penalized. But also on the flip side of that, there was no guarantee that you would earn any incentives. And so now there are minimum dispatch hours for VPP, VGI, and other non-residential aggregator options. There's also the expansion of day of events for all participants. Previously, some aggregators weren't eligible for the day of events, but now it'll apply to all non-residential participants. And then the last thing is sub-metering options for select participant groups. So a lot coming in 2022. That's it that I have to present on the ELRP. But if you're interested in learning more, you can check out our website. We are in the program website. We're in the process of updating it to capture the changes coming in 2022. The CPUC also has a webpage that has a lot of information about the emergency load reduction program. And if you're really interested, you can read through the CPUC's rulemakings and decisions related to the ELRP. Reminder, we're hiring. So again, for several roles, check out our careers page to apply. And then if you want to learn more, contact me. I have my email and my LinkedIn here, as well as our website. And if you apply for a position, or if you have some questions about the position, please reach out to me. I think that is it. Yes.
Awesome, Abby. Thank you so much.
Great, thank you.
A few questions, and I think we'll jump into Henry's talk and then we combined questions afterwards, because there'll probably be some overlapping ones that can get shared responses and so forth.
If they're direct questions, maybe it might make more sense while everyone's fresh to just answer those quick ones. I know there's one about complexity of program design.
It's in the chat. Why was the program designed to be so complex? In other words, what prevented the program from having a simpler design?
Yeah, that's a great question. And I think the reason it was so complex is because there were so many participation options. And the reason there were so many participation options was because, and this was all ordered by the CPUC, it wasn't the utilities design elements, but the reason there were so many participation options is because they wanted to get access to as much load reduction as possible, given the forecasted supply shortages. I mean, I can't speak for the CPC, but I'm pretty sure that is their reasoning.
All right. Any other direct questions right now?
I have maybe a quick one, and if it's too specific, we can not go into it. But first of all, Abby, super interesting. Thank you for sharing. I just, in the very beginning of your talk, you mentioned that Olivine offers this valuation model and that included an impact analysis. And I guess I was wondering if that impact analysis was like an upfront global assessment, or if you also own the analysis of how individual participants are delivering.
Yeah, it's a good question. And I'm not as involved in the development and utilization of our evaluation model, but if you shoot me an email, I can connect you with the people that work on that, and they can answer that question.
Okay, cool.
All right. Going once, going twice. Thank you so much, Abby. That was awesome. Henry, you are up.
Good evening. I'm going to share my screen and we'll get started here. And a similar offer stands. Feel free to interrupt or raise your hand, make some noise if you have a question midway through. I'm always happy to answer questions as we go, because it'll probably make more sense interspersed.
One other thing about WattTime is a non-profit, and they are one of the latest, and perhaps the latest nonprofit on the Atmos platform. So you can get a tax-deductible donation to them. If you give a tax-deductible donation to them, will increase your savings rate. So it's a double win, maybe a triple win. All right.
Just saw that in one of our internal chats recently, which is exciting. As Ravi mentioned, we are a nonprofit. So I thought I'd give a little bit of background on WattTime. And since we're kind of shifting gears away from demand response more towards emissions response, I thought I'd give a little bit of context on how we think about grid emissions and why we talk about marginal, not average, that type of context, and then how WattTime actually drives impact with that data. And then go a little bit deeper and say, here's what we do, here are some of the models we build, here are some of the data sources we rely on, and some of our future projects to pique everyone's interest there as well. So a little bit of context. Our mission is really giving people the power to choose cleaner electricity. And what that really means is we draw as many insights about the electric grid as possible, emissions-related insights about the electric grid, and then make that data available to provide authentic choices to consumers with our partners. So the variety of people we work with is to be able to let people understand where their power is coming from and make informed decisions based on that. And we were kind of formed out of a hackathon or a bunch of students getting together at Berkeley almost a decade ago now. And we've been slowly growing since then. We are 24 right now and hiring like mad. If you know anyone who's interested in modeling or engineering, I think everyone is at this point hiring, that is. And I think our key insight is what we really do is measure the marginal emissions of the electric grid. So what that means is when you change your electricity demand, how do emissions change on the grid? And from that kind of basic information, a handful of different ideas emerge out of that. And so kind of one of the more fundamental one is the timing-based one, where we say, can you consume electricity during those low emissions periods and avoid those peaks? And I'll go into a little bit more detail there about what we mean by that. But before we do that, I thought it would be good to build a foundation of what do we mean by marginality? I'm sure this group has probably seen a dispatch curve. This is a kind of a grossly simplified one, but a light speed review of it is this is each resource in that electric grid arranged by its wholesale price. So at any given demand level, as that demand changes throughout the day, different units will dispatch and set the marginal price. And then our goal is to detect what is the emissions of that changing marginal resource. So if you change your demand, how do emissions change? And so you can see it in this particular case, as you add demand, a new marginal resource turns on that might be significantly dirtier than the other resources. At other times of day, that could be much cleaner when we're throwing away solar, which we do considerably in California. Has everyone seen a chart like this or kind of grappled with a dispatch curve? I'm getting most nods, which is fabulous. Of course, I like introducing that beautiful clean chart. And then the first thing I say is we don't actually do it that way. That is much too clean and the grid is much more complicated than that. We use regression-based approaches and causal modeling to identify that marginal emissions resource, which I can dive into later as well. One other thing I like to highlight is that we are careful to report emissions at the balancing authority and ISO level, not the utility or other political boundaries, because we think that ISO and balancing authority better reflects the actual grid operations. So for example, Southern Company is a vertically integrated utility, so it manages its own resources. But in California, PG&E, all of the CCAs, SoCal, Edison, all of them bid into the CAISO market, and the CAISO actually dispatches the resources. And so we're always careful to pick the boundaries that we think best reflect that the actual grid operation. And then we are able to, in the ISOs, we're actually able to identify subregions based on congestion, but outside the ISOs, in the balancing authorities, we typically do whole balancing authority marginal emissions rates. Any questions there before we dive into some of the use cases? I will keep going. So kind of built on this data, we've kind of identified a handful of different use cases, really fundamentally deriving from two insights. One is timing-based and one is location-based. And so I'll quickly talk about what we call automated emissions reduction, which is the timing-based approach, and then also emissionality, which is the location-based approach, where you change your investments based on the displaced emissions in different grids. And then finally, I'll very quickly touch on helping building designers design more efficient buildings. So we partner with mechanical engineers and the like. So to dig into the kind of automated emissions reduction example, I know someone from WeaveGrid is here, so you'll probably have useful insights here, but automated emissions reduction is fundamentally, we have an API that delivers real-time and forecasted marginal emissions rates that can be integrated into the control systems of device companies. So in this example, it's a charging company through Enel. I think Ryan's here as well from Enel, NLX. And what we're able to do is schedule that load throughout the night in the charging window. So we take it away from immediately charging that vehicle and delaying it to what we think are the cleanest times during that night. And the forecast is of course not perfect, so we won't hit those periods perfectly, but we're able to shift that load and rely on more efficient marginal gas resources than the peaking plants. If you're doing day charging, you can pick up that curtailment in the middle of the day and avoid periods of natural gas generation. And so this whole system is really automated and intended for integration with devices directly. We have a partnership with Nest thermostats, where the thermostats automatically adjust their set points in response to a grid emissions, the changing grid emissions. And so you can see how this can apply to any device that has any type of load flexibility. Smart hot water heaters that have thermal storage, HVAC systems which have some kind of lag either in thermal mass or in the air or the water in the system. Pretty much anything that has that kind of flexibility. Actually, before we go there, I think one departure from traditional demand response is we're talking about continuous optimization. This type of optimization needs to be done every single day to really achieve significant emissions reductions, because you're really continually arbitraging and enabling that kind of emissions reduction. We think DR is really good for kind of emergency focused or urgent needs on the electric grid. But if we're gonna kind of transition to a completely renewable driven grid or zero carbon, depending on which definition you're using, we'll need this type of load flexibility to be always responding to dynamic changes in the electric grid. California is slightly more predictable because of the oversupply of solar, but in the Great Plains and Midwest, the wind is much more dynamic and unpredictable, so you need this kind of real-time response. We also see that people don't really want to be making these decisions every day about scheduling their dishwasher, like, oh, I should delay it 3 hours or 4 hours. So if it's integrated and you just have to elect to use it, that your device will automatically be able to respond to the signal. So that's like, as long as your EV is ready in the morning, you don't really care when it charges overnight. Similarly, you don't care when your dishwasher runs, as long as it's ready in the morning for you to unload. So we're trying to identify these opportunities where there's unexpected flexibility in appliances and electricity consuming devices. Before I get into, here's just a really simple co-optimization slide, or really optimization slide. Any questions on the device optimization? I saw Hitesh smile at my, it's not actually co-optimization. We just added two signals together to make optimization possible. We have seen that a lot of consumers are actually surprisingly motivated by environment, more so than necessarily the small cost savings that they might be able to achieve from efficiency or cost arbitrage or DR. And it's actually a driving reason that a lot of people are, purchasing EVs, electrifying their homes. And we're adding one more capability to kind of the arsenal of things that you can do to help decarbonize. So we're always cautious to say people may not be motivated by the TOU differential, but if we make it easy to take advantage of the carbon signal, that might actually move more people to a dynamic load control. And one thing that we're seeing is that one question we get often is, well, are price and emissions in conflict? And we say not necessarily. You can actually stack the values in the sense that if you consider the TOU rate as kind of a relatively fixed, non-varying signal, then you add in the carbon signal on top of that. And if you scale the carbon price appropriately, it won't swamp the TOU signal, but it will still provide differentiation within those blocks. So the combined signal still identifies this as the high cost dirty period to avoid, but it says, oh, actually, if within this TOU window, there's some good times to charge and bad times to avoid. And you can see, like, you're still getting the utility that you want from a price standpoint, but also getting some carbon benefit without affecting your bill or comfort. So we think that's an important kind of compromise that can be made with and still get both outcomes to a large degree. that's so fundamentally this AER is really a timing focused approach where we're saying you're in a location, you have a type of load that can be moved. Can you maximize the environmental benefit of that load? Can you sop up excess renewables or rely on more efficient natural gas generators? We also have conversations with large corporate buyers of renewable energy, VPPAs, PPAs, and have the conversation with them. You might have load in a particular place, but can you develop your renewables in a place where they have more impact? So this is just a map showing for every megawatt hour of new energy you add to a grid, the darkness of the plot indicates the emissions benefit per megawatt hour that you have. And you can see that that's not evenly distributed throughout the US, and there can be a 2 to 2.5 difference depending on your location. So building a solar farm, another solar farm in California potentially will cause more curtailment at certain hours, whereas building the same number of megawatt hours, let's say in West Virginia or the Great Plains area, will actually displace coal instead of a mix of solar and natural gas. And so seems like an obvious insight, but a lot of the current accounting practices treat all megawatt hours the same. And we're really saying you should actually think about what those megawatt hours mean. And from a kind of a nuts and bolts approach, we actually will partner with corporates as they put out an RFP. Once all those responses come back, we will measure the avoided emissions of all the different projects that are under consideration for a VPPA, and then rate them and integrate that into the decision-making process. So there might be a bunch of prerequisites, the pre-checked items here, where like it has to meet certain risk and performance criteria. But once that threshold has been met, there may be 10 or 15 projects that look attractive, and we say, can you use emissions as a tiebreaker? And so we would say, like, go for this project over that project because it avoids more emissions or produces more megawatt hours. So you have to trade like capacity factor and total megawatt hours against the avoided emissions and the risk and all the other kind of criteria. Even the more sophisticated partners look at far more than emissions. Like we've had partners, specifically Salesforce, look at health damages, habitat impact, local development, and start balancing those different priorities, saying, is there a project that achieves more of these outcomes than another? And we're really excited about that. And then finally, building designers like mechanical engineers, energy modelers, often make decisions about the systems and shading and kind of design decisions in the building. And we're trying to give this emissions data to them as a design tool to help make those insights. Like, should the shading be west facing or south facing? Is there optimal orientation for the renewable energy that looks beyond just the energy savings? Because a lot of metrics have been cost or energy savings in like LEED or even TDV is a weird hybrid of all the things. But like ASHRAE 90.1 relies a lot on cost and energy metrics. And we're saying the thing we actually care about is the emissions, not necessarily the megawatt hour savings. And so we've kind of, there's a lot of quirks of building energy modeling, like they use they use selective historical weather data to build their energy model. So how do you match that data? It really matters what weekends line up properly with the emissions data and the occupancy schedules. And so we've tried to build solutions that bridge that gap. Any questions on the different use cases before I dive into some of the stuff we do underneath? Excellent. I am recycling an old slide because it's so important, but one of the things we are very keen to focus on is that causal link between a change in load and a change in emissions. And we do a lot of very kind of sophisticated modeling where we suck in as much data from the grid operators as we possibly can. That can be from the EPA or the EIA, because they have very interesting like unit level emissions data sets that can then be aggregated up and manipulated in different ways to understand, can we identify amongst these set of units which ones are responding to a change in load? And so that's a lot of what our research team does, building out kind of research and engineering. They're somewhat a lot of the work is done by both of those folks that are on our team, where they pull in new data sets, identify the interesting features, and then build kind of complex models on top of that to kind of extract key insights from that data. And right now, the US and Europe, Australia, maybe Taiwan and Japan are some of the places where it's possible to do this because the data sources available there are very granular and detailed. Taiwan, I think, has 10-minute level stack emissions data for a lot of the units operating on the island. And so we're able to build very sophisticated models on top of that data. Outside of those regions, we start to run into problems where maybe the grid operator doesn't publish any of that information. And there's very limited transparency. And so we've actually launched a project to use satellite data or remote sensing to begin to detect when plants are operating and what kind of key indicators we can extract from them to start building out a kind of a global data set of the type that we have in the US for stack emissions. And that means what details, like, can we look at plumes? At one point we were wondering if we could look at cars parked in the parking lot to see whether plants were operating. Can we detect the thermal expansion of the stack itself down to the millimeter level? So a whole kind of many different types of kind of machine vision type of detection that we can get. So visitation frequency is really important. Is a satellite passing over the same point at the same time every day? Can we get satellites that actually visit at random times to build a more robust data set so that then we can start interpolating in more intelligent ways? And so that was kind of we want to build this capability globally so we can offer this to our partners and achieve impact in the ways that we've discussed. And so it really started to rely on kind of unique data sets that can begin to answer that. We have, of course, expanded beyond the visual range pretty rapidly and are working on stuff like that.
One question in the chat, if you want to take it.
Zeno said, are you familiar with the Watt Diet program where residential electrification is accomplished without increasing the panel size? This seems to involve some sharing between appliances within the residence of panel slots. How compatible is this with, assuming you mean AR, with this approach? I'm assuming you mean if you have like a dryer and an EV on the same circuit, is that what you mean?
It's that the Watt Diet also includes, so in a 100 amp panel or 125 amp panel, it's like, how do you fully electrify the home without needing to go to a 200 amp panel? So there are 120 volt heat pump hot water heaters. So instead of going for a 240 volt, maybe 60 gallon tank, you'd go 120 volt, 100 gallon tank. So it's like looking at things to fit within the same panel without upgrading that aspect of it.
That makes total sense. And from the conversations we've had, we don't see that as an obstacle. It's just another constraint on the optimization. So for example, if you have a smaller heat pump, it's going to need to run more frequently, potentially, to provide the same amount of heat, even though the same amount of energy is being consumed. So we would say instead of needing 2 hours of charge in an 8-hour window, you might need 4 hours of charge in an 8-hour window. So that would reduce the emission savings opportunity from a flexibility standpoint, but we could still achieve pretty significant savings in that context. So I would say not incompatible, it's just another layer of constraints.
Let me clarify a bit. So my understanding of the Watt Diet is that sometimes it requires within the house the sharing, I call it a slot on the panel, it's probably not the right word, sharing that slot between different appliances. So that would exclude maybe the, I don't know how you send a message to the dishwasher to start running. Is that through the panel? So I'm asking about that. If you have two different appliances on the same slot on the panel, how can you still manage that demand on the grid for that particular household?
Absolutely. So in that kind of slot sharing or circuit sharing scenario, I would assume that there's something orchestrating them, telling one that it can or cannot turn on or off, in which case we would also probably plug into that command and control center and say, can you add in different types of delays for emissions in addition to ensuring that both appliances aren't running at the same time. And so most of our partnerships are directly with device manufacturers who take the signal and redistribute it to their devices to make because they have the most insight about those devices, so they know if it's on a joint circuit, or if there are many people home, they need to run it harder, or what the usage pattern of that customer might be and how they can achieve flexibility there. So we partner directly with the device manufacturer to send that signal to the end use device. Does that start to answer your question?
Yeah, thank you.
Fabulous. I quickly want to touch on so with that climate trace, with that remote sensing project looking at remote emissions from space, we realized that there's kind of a large gap in emissions accounting globally, or emissions measurement globally, in all sectors. While we specialize in the power system, other folks specialize in agriculture or transportation, whether that's shipping or ground transportation. And what we've done is we've kind of built a coalition of different partners, kind of brought together by Al Gore, where different partners are using remote sensing to detect emissions of different sectors, so that we have better insight into global emissions. For example, RMI, I think, is focused on oil and gas. Ocean Mind is very focused on shipping. Blue Sky Analytics a lot on wildfires and air quality, and transition zero heavy industry. So each one of us is bringing a different piece to this kind of remote sensing story, where we're able to hopefully begin to identify where the largest sources of emissions are and how we can start to use that to bring those emissions down. And we're optimistic that it'll hopefully contribute to identifying solutions and ways to reduce emissions more quickly. That was pretty much everything I wanted to touch on. I think we'll open it to questions here, but also feel free to reach out to me with any specific questions or ideas. Let me stop sharing my screen. Zeno had a specific question, it looked like.
Yes.
What % of total emissions for the grid can you avoid? Do you mean through load flexibility scenarios?
Right. So I'm kind of trying to get a sense of how impactful your approach can be, maybe in comparison with other needed, like tightening of the shell of the house. What is the kind of relative importance and impact of this approach?
Absolutely. That tends to vary significantly by grid region. It also is a bit forward-looking. So, for example, in California, we are throwing away gigawatt hours of solar energy every year. And so we know that if we can take more advantage of that, we will directly reduce emissions. If we can avoid the evening peak and bring that into the midday trough, we'll just throw away less solar. And if we are able to do that, that also sends a signal that we can build more solar. It's arguably a cheaper form of energy storage. So it might require less investment in large storage projects as well. We see it as like a mix of storage, transmission, and load flexibility is enabling a fully carbon-free grid of the future. And we're using it today to kind of build that capabilities. Zeno, does that make sense?
Yeah, thanks. Yeah.
I see Aaron's hand is also raised.
Yeah. Hi, Henry. Awesome talk. WattTime seems like such a cool company. It's like really fun stuff to work on. So I'm curious, it seems like mostly you're thinking about kind of behind the meter optimization as one of your primary impact. I'm wondering if you have any kind of sense for how different the dispatch of these systems, if optimized against like WattTime's marginal emissions data, is versus if they were dispatched using something like a wholesale electricity price signal. Time seems like such a cool company. It's like really fun stuff to work on. So I'm curious, it seems like mostly you're thinking about kind of behind the meter optimization as one of your primary impact. I'm wondering if you have any kind of sense for how different the dispatch of these systems, if optimized against like Watt Time's marginal emissions data, is versus if they were dispatched using something like a wholesale electricity price signal. I don't know if you've ever looked at anything like that.
We have extensively. That's a very complex question,
Yeah.
which is great. No, so
Yeah, like let's pretend it's just like day ahead energy prices or something.
so marginal emissions rates and wholesale prices can be correlated, but are not necessarily always the same. In California, they tend to be pretty well correlated because natural gas efficiency and solar tends to line up pretty well with prices. Outside of California, when you start getting coal in the mix, that might be interspersed in the dispatch stack, there's no guarantee that marginal price will align with emissions. So you might actually want to load during mid-load periods when the more efficient natural gas plants are running before you dip into the coal response.
You don't have any like, we can definitely take this offline, but if you have any references for data around that, I'd be curious to see it.
There are quite a few academic papers that have dug into this question. I think we actually wrote one. I don't know if you heard of the Clean Peak Standard in Massachusetts. It's we think it's something of a misnomer because it's actually a cost management strategy more than a emissions strategy. We encountered the same problem with SGIP, but that was because the retail rates were misaligned with the wholesale needs, which is not unusual, especially with demand charges. We also see that a lot of the wholesale insight or wholesale prices are not passed to most end consumers. So this is a good, like, price volatility is difficult for me as an end consumer to
totally
so
anticipate in any way.
And so going back to the co-optimization, you get your emissions outcomes and your bill isn't affected, is something we think is important.
Cool. Thanks.
There's quite a few questions in chat, and Hitesh has his hand up too. Abby, Henry, thank you so much. I got to run, my wife's here, but please also put your emails in the, I know you showed them on the slide, but please also put them in chat so people can get them more easily, the little copy pasta over to their email platforms.
So in addition to Hitesh, there's also questions in the chat from Nick, Crystal, myself, and Clive. And I think most of these are for Henry, but Abby, if you have anything that you'd like to chime in on, please feel free to do so as well.
Yes, should we start at the top, or Hitesh, do you want to ask your verbal question first?
Henry, I defer to you. If you see something exciting in the list of questions, take it. Otherwise, I'm happy to share mine.
Why don't we start there with you, Hitesh?
Sure. I have two very kind of different questions. One is, can you share like what are some of the most exciting, say, consumer products that are Watt Time enabled or will be Watt Time enabled soon? Is that something you can talk about?
Absolutely. I think we're especially excited about the Nest partnership just because that brings a lot of visibility, and there are a lot of Nest thermostats. Also, our partnership with NLX's JuiceNet Green EV charging, that EVs are such a large load and they're going to be a growing load. Like, the energy consumption of vehicles is almost as large as our current energy consumption. So during that transition, we think EVs are going to play a key role in load flexibility. And if they're controlled based on a dynamic signal, we think it'll make renewable integration much easier. We're also doing some research with UC Davis through an EPIC grant on heat pump hot water heaters. And so I would say it's a whole variety of different things we're pretty excited about. Yeah, we have some things in the works that I can't mention.
And then the second one is from the satellite imagery. You did suggest that your transition away from the visible spectrum. I'm curious what parts of the EM spectrum have been the most insightful in terms of the greenhouse gas emissions.
I would have to defer to some of our satellites experts on this, and we can always dig into that if of interest. But it's really, plumes are visible, like condensation plumes from certain types of power plants, but certain power plants use dry cooling. There are some use lake cooling. So we have to use a whole variety of different a suite of different detection techniques. Awesome. I'm going to scroll to the top of the questions. I'm going to just start reading them.
Sure. So the first question was from Nick. Nick, I don't want to put you on the spot, but if you do want to come on to ask that, I think you were just hoping to get a overview of the various climate trace platform specialists and what their unique specialties are. Would that be correct? And sorry, if you're not available, that's fine. We can certainly take this offline, but well, I'm not sure if that's something you want to speak to immediately, Henry, or if that's something you prefer to take offline.
I just dropped the climate trace link in the chat, and that
does that have all the different folks on it, the ocean and they're all part of the consortium? Because when you were talking, it sounded as though they concentrated on different functionalities and different sectors. So I was just trying to understand if climate trace wrapped up all those different practitioners were tracking emissionality on those different, and that's all. It was just a fairly, do we go through climate trace, or do we talk to each of them individually and directly, is what I was asking, Henry.
Climate trace is doing a lot of the orchestration, and each of those specialists are looking at particular emission sources. So climate trace can direct you to the appropriate partner if you have
absolute thanks. Thank you so much for a very good presentation from both you and Ms. Shelton. It's a very useful and functional and valuable presentation. Thank you, Ravi, for putting it together. I got to jump.
Excellent.
Great. And I think, sorry, Aaron, before we go to you, can we have Crystal's question about, can you speak more about your heavy industry emissions findings? I think that this is for Henry when you were going through your, and Crystal, please feel free to jump in if you're on the line as well too. But I think that this is when you were talking a little bit about the satellite imagery and the emissions tracking from that.
I don't know of any of the direct insights or what kind of questions you're trying to answer here, Crystal, but I think Hypervine or Transition Zero would probably be able to answer those questions very specifically. There's an open data set, so we're looking at, I think it's everything from mining operations to cement to kind of chemical plants. All of that are included in the cluster of information.
Awesome, thank you. And actually, I had a quick question, Henry. So what is the biggest barrier that you see for onboarding device manufacturers for implementing the automated emissions reduction?
We see a handful of sticking points, and Abby might actually jump in here with some more because might have some insight into device optimization, especially with their partnership with MCE. But we see a whole kind of range of different capabilities at different device manufacturers. Some have no control capabilities of their device, so it's hard to do anything with them. Connectivity can be a big issue if you lose connection with that device perpetually. Convincing executives that this is a priority, that emissions is a priority for their consumers, can be hard. So it really depends on the organization and the priorities. So we spend a fair bit of time exploring options with partners, saying like, what does this look like for you?
Sorry, if I can just ask a quick follow-up, is the layer for automated emissions reduction, where does that exist? Is it in the firmware, software, or in the actual hardware? Is there any added cost for implementing that?
Yes, it's all of those places. So we've seen different partners do it in different places. We've seen cloud dominated, where the cloud collects all the information and sends commands to so retrieves information from us, and the device makes optimization decisions and sends commands to the device. We've seen that information routed directly to the edge device. where it does its own computation, makes its own decisions about when to shift load. And we see if you've already built some kind of optimization capability for your device, adding in emissions is a relatively low lift because you can treat it as just another signal amongst many. But it tends to require some development on it. It's typically a development effort, not a hardware effort, if that makes sense.
Thank you.
Abby, would you add anything on the obstacles for controlling devices? That's been a huge topic for us.
No, I was thinking about, David, your question that you put in the chat. Do you want me to try to answer that one? I don't know.
If you know, we're jumping a little bit ahead, and I don't want to hop the queue, but if you are able to speak to that, I just would like to learn a little bit more about whether Olivine's platform is primarily for non-residential PG&E customers, or if it's for you know, given that the 2022 ELRP seems like it's unfolding to more customers, I'm just curious what the plans are for Olivine going forward.
Yeah, so our platform is not just for non-residential PG&E customers. Our Olivine DR platform is used across a wide variety of our utility and service provider clients for a lot of different programs, and it supports, you know, residential customers, non-residential customers, so direct customers, but also all aggregator options. So it's designed in a way that it can meet the needs of various programs with different goals and designs.
That's awesome. And it does seem like Olivine is generating a ton of value by, you know, orchestrating these programs and allowing participants to be involved with this. But I'm just curious how Olivine captures that value. Is it just from that rate differential that you know, $1 or $2 per megawatt that PG&E is offering for reducing consumption during those periods?
For the emergency load reduction program, that is the main value to the customers. For other programs, it really depends on the program design and the goals. There are definitely other value streams for customers and for the clients, like the utilities and service providers. But for the ELRP, the $2 per kW is the main driver for customer participation and the value that they get out of the program.
Great. Thank you. So I think our next question is from Clive. Clive, do you want to go ahead and ask your question live?
Yeah, so Henry, I've been following you. I'm in New Zealand, and we have, I'm actually doing a master's on it, but I just wanted to know really about how so you talk about California, which is a massive grid, but once you start averaging those emissions, then you you've got locationality to some degree, but I'm finding here that there's grids which are 100 kilometers away, and one will have zero emissions and the other one will be predominantly fossil. And I was just wondering if you're getting into that level of granularity.
We're very careful to kind of identify those seams. In New Zealand, we understand that there's a pretty large divide between the, like, north and south, and that there's a transmission constraint there as well. We've been talking to some folks in New Zealand as well and having some very interesting conversations about emissions reductions in their cap and trade program and what that means. But what we've seen with hydro is if there's consistent export, this is true in like BPA, where a lot of that hydro is exported to the smaller utilities in Southern California, that hydro is only curtailed during super low load events or the spring during high flow events. So when water is being spilled over the dam, we consider that's an opportunity for increasing load to decrease loss of that resource because it's no longer being captured behind the dam. Outside of those scenarios, we don't consider hydro a curtailed resource because of its kind of storage capacity. I think I did a little bit of reading on New Zealand, and there was a major court case a couple of years ago, or even like 1 or 2 years ago, where there were water releases in the south of the country while there was an energy shortage in the north, and that was actually a situation where you would consider the south having curtailed power, zero emissions power, and the north relying on fossil resources. And so those emissions rates was diverge. At other times, there's consistent enough flow and you can just export the power through that connection. Does that begin to answer the question?
Yeah, I think it's yeah. I mean, it does. I guess you might have spots. I mean, if you think of electricity in California as not being able to, a unit generated in the north can't make it to the south efficiently, then you can have pockets of fossil even within a clean grid. Do you know what I mean?
Absolutely.
Yeah, and yeah. Okay, no, that's fine.
In the UK, I think we're actually seeing this even the opposite pronounced, where there are rules against exporting solar. So you're getting on-site solar curtailment because there's no way to store it and there's excess. And so you can consider that hyper-localized solar curtailment. So you'd want to increase demand during those periods. And then a lot of the older grids in Europe have a lot of distributed grid edge resources, which cause all kinds of problems, like pockets of load pockets and stuff like that.
Yeah. I know. It's great work that you're doing.
Great. So next up, we have Aaron, then Hitesh.
Yeah, thanks. So I think you mentioned that you both monitor and serve real-time emissions data, and then also you forecast emissions. I'm just curious, what's the kind of breakdown between consumers' interests in those two products? And on the forecasting side, like what kinds of horizons are people interested in? I assume it's not the kind of day ahead horizon of the electricity markets. You can be like shorter term than that.
Absolutely. I would say the split is more between historical data and the whole suite of real-time data. So we see a lot of partners interested in historical data who are doing analysis or want to identify power plant siting opportunities, stuff like that. So that's a kind of an analysis-based data set. And then folks that are interested in control tend to want the forecast as well as the real-time data, because the more sophisticated partners will actually take the forecast, identify a threshold over and under which they think their device should be operating, and then take that real-time data and say, your forecast is going to be wrong, which we acknowledge, and then act on the real-time data, because it's much more dynamic than the forecast. Does that make sense? So you kind of make a plan based on the forecast and then update it in real time based on the real-time data.
Interesting. And that plan making stage, is that also do you have any idea like how far out people are planning around emissions?
We tend to find that is highly dependent on the device. Agricultural pumping, they want a week because they make decisions that far ahead. We've talked to some software partners that do week ahead planning as well, just for updates and stuff like that, or machine learning model runs. They're like, yeah, we have weeks of flexibility.
Yeah.
We hear a lot of demand for 72 hours and below. So that's currently the range of our forecast.
Okay.
People
That's
tend
still pretty
to be
long
making,
though. Yeah.
Yeah, people tend to be making that type of decision. Like if you have a battery, hot water, hypothetically, in a tank can float through periods that long. Smart thermostats, maybe a couple hours. So it's hyper device dependent.
Yeah. Cool. Very cool. I admit I have a forecasting bias because that's what my company does. So pardon the specific questions.
Oh, we have conversations about accuracy versus efficacy internally at WattTime.
Let's take it offline.
Okay, excellent.
Thanks.
Hitesh, you also had a question?
Yeah, I'd like to turn back to Abby and see if she wishes to forecast for us what the future of ELRP might look like in California. I'm just kind of, this was an emergency thing, and I'm curious if you have a sense of where we're headed with it.
I think this year is going to be really exciting with the new participation options, especially the residential option. The fact that a lot of all residential customers really for the 3 IOUs will be able to enroll in a program and be compensated for load reduction during these times of grid emergencies. Because previously a lot of people were reducing load, but they weren't being compensated for it. And so for customers to have that opportunity is really exciting. I think we're going to see a lot more engagement from residential customers. I'll be able, everyone here, for those of you that are from California, will be able to enroll. And so that's exciting. And some of the new aggregator participation options are exciting. Like I mentioned, the vehicle to the VGI aggregators, vehicle grid integration aggregators. I'm excited to see what comes of that. And yeah, I think that hopefully, I don't hope for any grid emergencies, but if there are some, I hope that we're prepared and we can respond.
Do you have levels of participation, or did you have any like megawatt numbers of folks that enrolled, acted, etc., paid out, that type of stuff?
Yeah, that's a great question. I unfortunately can't share, those numbers aren't public, and so I am hesitant to share them. But yeah, that is a good question. And
is the PUC planning to publish any of that information?
I'm not sure.
Totally legitimate answer. Thank you.
Can I squeeze in a follow-on question to that? This is also highly specific, but like, I feel like I know multiple people that have electric vehicles and they're like, what should I do with charging it? Like, what's like the device people should get to do very, very easy, like control by WattTime or vehicle to grid program?
Those might be different answers.
And which one should they do? Not to pitch you against each other.
We work with a variety of partners, some more sophisticated than others. NLX has a charger that does pretty sophisticated controls for EVs, and we're always working with them to improve it. I can't say yet who, but we are also working directly with some EV partners to put the control in the device, in the vehicle directly, because often there's more insight there as well. Abby, do you know which devices are well integrated with DR systems?
No, I'm not as engaged in that at the moment, so I can't speak to that.
Another hack, which might be useful, is that a lot of apps use your login to be able to control the vehicle directly. So there are some partners that are actually controlling devices directly through the vehicle. I believe Grid Savvy through MCE might be doing a fair bit of this. And that's I don't know the details of that program, but there's a lot of integration through the charger, through an app, through the vehicle itself. If you have partners or your friends who want to ask these questions, we can start digging into those directly.
This is a good start. Thank you.
So I wonder if we should be sensitive to, yeah, let's do Mark as our last question, and maybe be sensitive to Henry's and Abby's time.
Thanks. Yeah, I was just curious on the V2G side. I mean, are you for Abby, are you actually anticipating or expecting that you're going to get discharge of vehicles into the grid, or is this more load shifting?
Yeah, that's a good question. So it depends on, like, this year. Eventually, I think it will be both. And I have to dig through the various filings on the requirements around, because they have to meet certain requirements if they are going to export beyond load. But I think the end goal in the next couple of years, we should see compensation from and participation from both those that are just reducing their load, but also others that are exporting to the grid. I don't know if we'll see that this year, but I imagine the ELRP, I didn't maybe mention this, but it is a 5-year program. And so we've just completed year 1. We're approaching year 2. So there's several more years to see. I think we'll see a lot of innovation, and hopefully we'll see some, both cases, the VGI that are just reducing their load during events, but also those cases where they're expertise.
Thanks.
Great. So I'd like to just say thanks to Abby and Henry both again for joining us. Woohoo! Yay! And thanks for all of the folks who joined to listen in. And I know people have started trickling out because it's getting late. But thanks again, and we'll keep your eyes and ears open. We plan to do a number of events coming up in the next months, April, May. We don't have all the details quite yet, but we'll be posting them soon, and hopefully a happy hour outside somewhere soon. David, do you want to throw in anything else on it?
Well, just thanks so much to Abby and Henry. That was a fantastic presentation, and thanks everyone as well too for all the great questions. And we're really looking forward to having everyone for our upcoming next month is Earth Day, so you know, that's going to be a great event for us as well too.
Thank you all.
Bye, everybody.
Right all.
Thank you.